We heard something in the first section about vision, and in the second section, we heard about various new aspects of modeling and new ways of modeling, but also about a new vision about how human beings might live in the world. In our third session, which is being given by Stephen Brewis, Stephen is a modeler. He's a mathematician and a modeler, and he works in organizations. So the theme of model, it's a very different kind of model that he works with. Also, he does create visual representations. But he's also interested in how to use that in order to enable organizations to amplify their variety. So there's a certain connection with both of the previous speakers, a theme that's coming through. Stephen is one of our recent honorary fellows. He was made an honorary fellow this year. This was on the back of work that he did with British Telecom, BT, that he may or may not mention. But he developed a very sophisticated, large-scale VSM model covering a multi-billion pound, multi-billion dollar business division within British Telecom. And this was used operationally in a variety of different ways to support management, but also self-organizing teams. And having spent quite some time in conversation with him and diving into the bowels of this particular system, and indeed the meeting room where we met, I was very pleased to be able to welcome him to this particular talk. He's going to be talking then about how do we amplify variety in organizations. Stephen.
Thank you, Angus. So I hope everybody can see that. I don't know if you want to put your thumbs up there, Angus.
Yes, we can.
Oh, that's great. Yeah, right. I want to give an overview of the insights that I've gained over maybe 30 or 40 years in very, very diverse areas, and I want to bring those diverse areas together to demonstrate how we can amplify regulatory variety. And here I'm starting with an example of not being able to absorb the variety that the environment is throwing sort of at me. And I've had a lot of experience sort of recently in the North Sea, the entrance to the River Tyne, that's sort of continuously sort of throwing me overboard. So as Angus mentioned, I've spent a lot of time working for BT, and I was a chief research scientist up until about 2 years ago in the area of organizational science. Organizational science has always intrigued me. I always wanted to be able to understand how organizations work and indeed what coheres an organization. But towards the end of my time in BT, I was given quite a significant task, was really decommissioning the UK's TDM network. Now, the TDM network is the network that has been providing telephony services for customers in the UK for the past 30 or 40 years. And that's really coming towards the end of its time. And the challenge that I've got, or I've had, is being able to decommission it. And the problem I've got is sort of the decommissioning of a network is not the same as building the network. When we build the network, we go where the demand is, okay? So really, it's pretty straightforward where we go. But when we're decommissioning it, the problem is a lot more difficult. I've got effectively 6,000 telephone exchanges, 20 million circuits, 20 million customers, you know? So faced with that predicament, what is it that I do next? Which circuit do I remove first in order to be able to minimize the costs and minimize the disturbance of that decommissioning? But this is an example of how I'm trying to, in a way, take account of variety. And of course, there's a lot of people looking after the network. People are going to make decisions based on their understanding of the rules that we create in our research unit. So there's always the different interpretations of the rules. So in a way, we could argue that the system itself is starting as a complex system with a lot of people involved in making various decisions. And one of the ways of trying to amplify regulatory variety is to try to reduce the unnecessary complexity there is in the system. So if I can remove a lot of the decisions that are made by complex systems and make those decisions sort of the role of a complicated system, that is something really that I'm trying trying to be able to do. And what I can do by doing that is I generate a digital twin. I can put a lot of the knowledge in the heads of the individuals and the rules in our books that tell us how we should be sort of decommissioning the network. And to be able to do that, this is an example of a way of amplifying the variety. I've developed two key applications. One is about reducing the complexity for switching. So I've got an example here showing Tetris. So Tetris is about decommissioning a switch. I don't want to go into details, but the idea being is I've built a model to absorb the complexity, the complexity of the network, and I'm using the algorithm within the Tetris application to be able to decommission part of the network. The other part of the network comprises of transmission. So what I'm doing here, we've developed another application that is called Kerplunk, and I think we're very much aware of the game of Kerplunk. So Kerplunk is where we've got straws or transmission links in the network, and if we remove a transmission link, and we can decommissioning the nodes that transmission link is going through. So that was the type of work that I've been doing. So I've been sort of building models and using these models to be able to amplify the regulatory variety, giving us the ability of being able to absorb a high degree of complexity. But I want to briefly take you on that overall journey that's got me to where I am. So I started life many, many years ago as a sort of a marine engineer. And I'm going to break this presentation down really into two parts, and you'll understand why later on. I'm going to call it the pre-Stafford era. I'm going to talk about the pre-Stafford era now, and I'm going to talk about the post-Stafford era, and I'm going to try and link the two through a new concept that I'll come on to. So I was, many years ago, I was a marine engineer, and I've always been very experiential in my learning process. I don't like sitting in a classroom. I prefer to go outside, and I prefer to be able to talk to the world, carry out experiments to really understand what is going on. So when I reflect on that, if I reflect on my time in the Navy and how I was trying to understand the ship and understand the engine room, I was also at the same time trying to understand what's going on in the brain. So effectively, on the left-hand side is effectively a very simple model of my brain using a conventional way of being able to diagram a neural network. And what I'm doing is I'm interacting with a ship. And what I'm doing is I'm perturbing the ship. I'm going to try and understand maybe stability and how it actually starts to righten after it's been blown over by a wind. And I'll ask questions about that and how the displacement in the water may change. So I'm effectively sort of getting an answer back, and that then is being able to go back into my neural network. And at that same time, I'm actually increasing what I would call the shared white space of understanding. So this is the shared white space of understanding where the ship is talking back to me in terms of an experiment, and I'm absorbing that. So at the same time, what's going on? I've got the scaffolding inside my brain that will enable me to ask a question. When the question is being answered by the experiment, you can see the complexity of the scaffolding is increasing. But the interesting thing here, when I'm doing this and trying to understand what is going on, is I'm using the model to be able to answer the question. And when the question is answered, I'm making changes to the model to absorb the answer. Okay, so the model gets a wee bit more complex. You can see the scaffolding poles are starting to bend and twist and so on to be able to absorb the answer. So that's in a way how I'm trying to visualize the space of what's going on, is how I'm actually learning. And then I might then define intelligence. So I could argue that intelligence is the rate at which I'm able to absorb data or information from a given situation. So the overall shared white space in the center here, I'm just going to try and draw on here. We can see maybe the shared white space itself starting to be able to increase. So that gave me an idea of what is going on. So I'm using the world and I'm asking questions of the world, carrying out experiments in the world in order to be able to increase my understanding. So in the future, I become less intimidated by it. I did not want to feel intimidated by the ship when I'm in the middle of the storm in the Pacific Ocean and I don't know what to do. That to me is a very dangerous situation for me to be able to get myself in. So I'll just move on from that, but this is all pre-Stafford. So I've actually built a model. So if I move on from it, I'm just going to return from that. Later on when I was at university, And this really gave me an insight into terms of what models can do. Is I had a project to do, which was to just build a vibrator that would just vibrate. But I wasn't happy with that. I wanted to understand if I was going to build a vibrator before it was built, how was it going to perform? So I built a mathematical model of the vibrator in the computer. And what I could then do was to change the parameters of the model. Remember, I'm in my mid-20s here. I could change the parameters of the model and predict how it was going to behave. And indeed, what we would do is we would then go into the laboratory and we would build the vibrator. And what we would do is I would have a curve saying that this is the theoretical performance of the curve. And I would find out that the actual performance was just behind it. What really surprised me is that the theory taught me that this thing I was going to build was going to vibrate at 60 times per second. I thought that is just absolutely crazy. I couldn't find anything wrong with the mathematics, but I was able to do that, and I was able to then to make a prediction of what was going to happen in the future about something that had never ever existed before. So this is what's trying to reinforce the power of really the modeling paradigm. Since then, I've done work for the modeling of the KLM network, the entire network, to be able to understand more about air safety. I've also done this is going back again a number of years ago when I was working in an industry as a control systems engineer, and I was building models for laundries. And the problem we had there is that the laundry equipment would just work on a timer. It was a dryer, a large dryer for drying, I think the bedding and the linen from hospitals. And this was using a tremendous amount of power. And I wanted to find a way of trying to reduce the energy consumption of this laundry. But to cut a long story short, what it ended up doing is putting a thermodynamic model of the drying process inside the regulator. So the regulator had a model of the actual operation, which was a drying processor, effectively. So this was the first time I had stumbled across the law of requisite varieties. For me to start controlling the outside world, I needed a model of that outside world inside the actual regulator. I went on to do more work for the health service. I was a design and commissioning engineer for the health service. And this was the chimney that we actually sort of built just outside of St. James's Football Park in Newcastle. And you can see it from all over the place. And again, this was an example of modeling. The chimney was required to reduce the amount of local pollution and particulates falling on cars and so on. But another example of using a model to make a prediction of future behavior and doing that. So I was starting to really get very, very sort of interested in modeling. And I found out I could solve any sort of model using mathematics. And the last challenge for the health service is trying to manage the temperature inside the operating theatre. Here I'm showing an operating theatre with a laminar floor cabinet, and that's used for hip operations. A surgeon could be in a theatre for many, many hours, maybe 10, 12 hours, and they would get very uncomfortable towards the end, and that might affect their ability to be able to continue to perform at the top level. But an example of feedback and control is there initially, this is a slight exaggeration, but you'll get the idea. I was wanting to control temperature, and then we found out that the actual airflow across the surgeon was a problem after an hour or so. You started to feel very cold by the high degree of airflow that are required to reduce contamination. At the end of the day, effectively you could argue here that my skateboard, my minimum viable product initially was the temperature, controlling temperature, but the actual Rolls-Royce solution was controlling comfort. So I needed in my model, my regulator model for temperature improved significantly. Rather than having an on-off switch, I ended up having a very complex equation defined by Fanger's comfort equation to control comfort inside the operating theatre that, out of interest, also included the metabolism, the weight, the height, and the shape of the surgeon. It showed you the level of granularity we can go down to, and I needed to do that to absorb the variety of that situation and to maintain comfort. So this was my sort of pre-Staffordian world. Okay, I was building models, and I knew a bit about feedback and control. But then I was giving a talk in Florida maybe about 20 years ago. And there was a sort of an after-dinner speaker who had never come across before. And he mentioned a few words that actually created a paradigm shift in my thinking. And those key words were in the animal and the machine, right? And the person that sort of uttered those few words was, of course, no more than Stafford Beer himself. So what that meant to me, what did that really mean to me? See, the animal and the machine meant that animals were machines, right? Organizations then are animals. Animals are people. So animals are people. And what we can then go through from people, organizations consist of people. Okay, and businesses are organizations. That made a paradigm shift because that then gave me a chance of trying to model an organization. I used to think that an organization was a chaotic ensemble of people running around just doing things, and somehow that organization or that business system would be able to move forward. So he made a total change in the way that I was starting to think about the world. And indeed, I went on to get to know Stafford very, very well. He would come up to visit us at Northumbria and Sunderland University. And I've spent time with him and Elena in Toronto, and Stafford down in Lampeter in South Wales. So let's move on from that. So effectively, I will now take you into the world of business, into the business systems, where we've got people, we've got soft systems effectively and hard systems come together and interacting. And I've got to somehow try and tame that to get control. So now I'm using the term when I'm going into these parts of the company, like BT, is a cybernetic intervention. So here I can imagine I've got an organization that I just don't understand. I don't understand this organization. And I want to be able to think, how can I absorb the variety from all of these other dimensions I've just briefly taken you through, right? And Stafford, of course, and the challenge that I want to take at hand, of course, is the PAYPHONE organization itself, where I was applying VSM in totality in transforming the entire business. So I'm going to move briefly on to PAYPHONEs. The PAYPHONE challenge is that we were, the Northeast District was part of BT. There was 32 districts, and our PAYPHONE serviceability for BT was abysmal. It was down, it was running at about 57% of serviceability, and the target was 95%. So the general manager got me into his office and he asked me, Stephen, I'm in a really difficult situation. I've got the chairman ringing me every other day about our abysmal PAYPHONE serviceability. Derek Jameson on Radio 1 was a presenter on Radio 1. He would be continually knocking the PAYPHONE service, saying that when he goes up to a PAYPHONE, he never ever finds any PAYPHONEs working. So it was a real challenge. So I was given a challenge to try and transform and improve the serviceability of the PAYPHONE service for the northeast of England. And there we are, there is the conventional BT box. So let's start with an organization that I don't properly understand. And what I need to do is to absorb in my model the environment. And for the first time, I'm looking at organizations rather than looking at something like a ship, rather than looking at something like a laundry. This is a lot different. I'm looking at an organization that's got lots of people and lots of technology within that. So I started with the conventional view of the viable systems model. And what I'm going to do is I'm going to make changes to this because remember, I'm like a control systems engineer and I want to be able to manage not what I would call viable systems. I want to be able to manage individual elements, individual parts of the business as well. So what I've done is I made some minor changes to my interpretation of the viable system. And what I've done is I changed it around. So effectively, I'm turning this into a complete fractal. A fractal is something that is invariant to recursion. So it means I can recur through any part of that system. I can recur, which you don't normally do using the VSM, you normally recur through the system 1. I can recur through system 2 and system 3 and 5, 4, and 3. You can see I've got the same image against every object that we normally see in the viable systems model. And what I'm going to do now is I'm going to turn that inside out. Stafford never liked the way that he drew that because it had a type of hierarchy, but also that when he was actually recurring further and further down, he was actually recurring further and further down into a smaller and smaller place. So what I wanted to do here is to turn this inside out. Okay, so all I've done is I've turned that inside out. So here we've got the highest echelons within the PAYPHONE organization. I'm going to leave BT out for the time being. And here we can see we've got the system 1s here. We've got the embedded system 1s down here. And we've got the embedded system 1s down here. These are embedments within them. The important thing about that is we can actually see the entire organization. And some of the modeling work I do is I can use this for metabolism. I can show how money is being metabolized by showing the pathways from the centralized operating plan to the other operating plans that are tightly cohered through the entire organization. But coming back to PAYPHONE, so what I want to be able to do now is to show and demonstrate how can I absorb, right, all of these elements. How can I absorb 2,000 or 3,000 people, 4,000 or 5,000 PAYPHONEs within a distribution, within an environment where we've got fog. Fog's a problem with PAYPHONEs on the coast. You get a lot of dampness, moisture, and the PAYPHONE will no longer work. The quality of the maintenance is also a problem as well. So what I wanted to do is to somehow bring these areas together. So I would then identify from a modeling perspective that the fault rate somehow is important. If I have a high fault rate, there's going to be a problem. And the fault rate is a function of fog. Fog affects the fault rate. The vandalism significantly affects PAYPHONE serviceability, and also the workmanship. So I can bring these other areas together. The important dimensions of serviceability, of course, is the time taken to detect a faulty PAYPHONE and the time it takes to be able to repair that. So what I could do is I could then put that into an equation. But before I can do that, I've got to understand how these parts affect each other. So at the same time, I'm building an underlying digital twin model of the operation, so I can actually help to facilitate conversations between individuals. So this could be a typical conversation between looking at the faults in the network and looking at the impact of fog. We've got a shared white space that I've described before, and what we're doing is increasing as we increase the knowledge, the size of that overlap is going to start increasing, as I explained previously. So the size of that white space will start increasing and increasing. And I can support that through data. So prior to this, I'm building a data model so we can start answering the questions that are being asked by these two individual parties. So I think you get the idea from what we're talking about there. But the important step here that I want to be able to make is that when I was building this, I started to realize that the actual mathematical model was no different from the organization. The organization was a way of me being able to implement the mathematical model, which was quite simple, is that the serviceability was a function, was actually, I can be very precise, was 1 minus the fault rate divided by the number of hours in the year, multiplied by the time taken to detect the fault and the time taken to repair the fault. So what I was able to do was to be able to implement this, the mathematical model, and distribute it through the actual organization. So the organizational was really synonymous with the mathematical model. So the challenge that we had was to be able to improve PAYPHONE serviceability from 57.4 to 95%, okay? And at the end of that 6-month period, okay, we won the national award, you know, and we had a PAYPHONE serviceability at the end of that period of 98.7%, which I thought was very, very good. I didn't expect that. So I'm just going to finish off really with the last slide that really completes maybe my mental model, bringing all of this overall space together, where effectively we've got the Stafford's inverted view of the viable systems model. I've got embedded in this Teams integrity, which maybe you are familiar with. Teams integrity helps to be able to bring together a large number of people to be able to maximize the variety of their interactions. We've got a digital twin model of the operation, and we've got the actual operation itself. So that's just a way of trying to distill maybe my view, my 20 or 30 years experience in this space into a single diagram. So that's how I sort of believe, and that's maybe, the proof of the pudding is in the eating with the 98.7% serviceability, is how organizations amplify regulatory variety. Okay, thank you, Angus.
Thank you so much. Much appreciated. There are multiple questions, I think, about this. So I wonder if you might end your screen. Well, you might still need to show something from your presentation. So by all means, leave your screen share up if you want. There are multiple questions about what you've been saying in different modes. And I'm not sure quite how we can, in a single question, target it. But I wonder if you might just focus on one aspect. you create a model. The model is a kind of machine. You can correct me at any point, you know, either as I'm asking or afterwards, but you create a model. The model is a kind of machine in the sense, and it's mimicking some aspect of the world. The world has whatever detail it is, and the machine or model that you create has to find the level of detail that the world actually has. It has to replicate what the world actually does, and you go through processes in which the model improves in order to replicate that kind of detail, because if it doesn't, it's not going to be useful to you. And what you found is that you could create models that could replicate the world and indeed could design things into the world, and in your case that ends up with designed actions.
Yeah.
How can you just walk us through one specific aspect, the relationship between the variety that the world has, the variety of the model, and your variety as you go through your process, and how that is then shared with the people who are going to be using it, or the participants in it, or whatever?
Well, certainly, again, because the theme is an amplification of variety, Angus. So how do I, first of all, go about amplifying my variety, right? So I know that when I'm going into a new situation like the network, that really I don't understand much about the network. I've got the ability of building models, okay, but I need to be able to work with domain experts. So I'm working really with people who are working outside there in the overall space, right? So what I'm doing when I'm doing, so I'm very much aware, and also I'm also aware that I have a specific perspective on what I believe is maybe the overall problem. So the idea is to be able to engage the domain experts. But how do I sort of engage the domain experts? I will use my modeling expertise. So remember, I'm part of the team. And I think my idea is to be able to try and show how the knowledge can come together to be able to reduce the, maybe the variety. Remember, these individuals, these are domain experts, and they don't always talk to each other. The transmission planner will not always talk to a switch planner. So it means when we're doing changes to the switching network, that could jeopardize the transmission performance, okay? So the idea is that I'm the modeler. I'm going to build individual models of switch and transmission, but I'm going to start linking them together. But when I'm linking them together, I've got to demonstrate that maybe what I'm doing is I'm constraining the future for switch, and I'm constraining the future operations for transmission. And I'll explain what that really means, and how by doing this it will jeopardize what's happening on one side, and how working on the other side will jeopardize what's happening on the other side. So what I'm doing is I'm bringing the two together and demonstrating that by building a model of these two, how I'm constraining the future. The amount of future options we've got to unfold into is being reduced. You don't have the freedom you've got by working in silos. Coming together is difficult because I've got to help to facilitate the conversation. I've got to start now building the model in data so I can understand what the impact is of a switching decision on transmission and a transmission decision on switch, and take that forward in that sort of way, Angus. So that's how I'm engaging the individuals. I'm working with them. There are no surprises at the idea. I'm working with the people who are going to be using the model, and they can see the benefits from using the model. They can see that the job maybe they're doing is more interesting now. That they're talking to other people and so on. So I feel that's how I've gone about doing it, and making a success of it as well.
Thank you. That is clear to me, and I shall try and resist any kind of detailed replication. But the key things that come out of that for me is that you're filtering, you are bringing together and collating the different filtered expertise. So these domain experts, they filter their knowledge of the world by the domain in which they are the expert. But
Exactly.
then in their world, they have all of that detail. You can bring all of that together into the model. And those different participants bring, therefore, their richness, and you can bring that richness together and then feed it back in such a way that the interactions that may not be obvious to the sectioned domain leaders and domain practitioners, that the interactions between those become more obvious, and therefore planning can be done better. And if that makes any kind of sense, let's hope. We are going to go into our breakout rooms now. We will have Not very long, probably only about 10 minutes, because this